Hello everyone, this is Hani and welcome to my channel. Today I'm going to start the 6th lecture of the course MATLAB for beginners, and I will discuss with you the loop control statements, more specifically the for loop and the while loop. So let's get started. So the for loop is very standard and very straightforward. It has this structure here. So it starts with the keyword for and ends with the keyword end, and it contains this header here. It has a variable name, and then we have the assignment operator, and then an initial index, and then the colon, step, the colon, and then last index. And we have some statements to run here. Okay, for loop and while loop are used to repeat these statements, statement 1, 2, or as many statements as you want. It works this way. You have a variable name, and people usually use I. Okay, the index I, and then you increase this variable name from the initial index to the last index, and you increase it by this amount, the step. And each time you increase this index, this body here, the whole statements are going to run until you reach the last index, and then this block ends or exits. So let's take this example. So here we have the for keyword and the end keyword, right? And the variable name is I, and then the assignment operator, and then 1 is the initial index, and then the step is 1, and then 10 last index. That means I'm going to run this body here, the two statements here, this one and this one. We're going to run them 10 times from 1 to 10, and we increase by 1. So it's 1, 2, 3, 4 up to 10, right? These two statements are going to run for 10 times. We can see here that the first statement is displaying this text. This text is a constant text. It's not changing, right? So hello, this is a loop number. And in the second line, it's going to display I. When we start our first statement, I is going to be 1 because I starts as 1. Okay, so we say hello, this is a loop number, and then 1. And then we go to the first line again. So I becomes 2. Why 2? Because we increase by 1. So 2, and then hello, this is a loop number 2. Okay, and so on until I reaches 10. So when it reaches 10, we say hello, this is a loop number 10, right? And when it goes back to the first line, I tries to increase, but now I is 10. It cannot increase anymore. So this for loop is going to exit. Now, if you increase by 1 or the step is 1, you can omit it, you can exclude it from your code. So you can just say for I from 1 to 10, right? And then display. This code is equivalent to this code. The thing is, we use the step to define values different than 1. So let's take this example. For I assigned 1 and increase by 2 up to 10. That means 1 is changing by adding 2. So it's going to be 1, the first run, and then 3, 5, 7, 9, and it's going to end at 9 because if you increase 9 by 2, it becomes 11. So it's out of our range. Our range ends at 10. So we are going to run this statement, the body of the for loop, when I is 1 and 3 and 5 and 7 and 9, right? So this is all about the for loop. Now let's get to the while loop, and the while loop is a little bit different. We have the while keyword, the end keyword, and we have a condition. And we have the body of the while loop that contains several statements. Basically, in the while loop, we are checking this condition, if it's true or false. If it's true, we run this body. If it's false, we do not run this body, and we just exit the while loop. To understand it, let's take this example. X assigned 1, okay? This is not part of the while loop, but we need it for the condition. So we have a variable named X, and it has a value 1. And then we always check this condition. This condition is a question asking, is X less than or equal to 5? In the first run, in the first iteration of the while loop, this condition is true. Why? Because X contains the number 1 and 1 is less than 5. So we are going to run this body here. So this body is just displaying X and then increasing X by 1. Okay, so this code means we're going to have the old values here, add 1 to it, and store it in X again. So 1 plus 1 becomes 2, so X becomes 2. And then we go back to this line asking, is X less than 5? Now X contains a value 2, so it's still less than 5, so we run this again and again and again until X becomes 5. When X becomes 5 and we want to run this code, so X now becomes 6. So X equals 5 plus 1, so it's 6. And then we go back and ask ourselves, is X less than 5? Now x is 6. Okay, so it's not less than or equal to 5, it's false, so this body is not going to run and while loop exits. So this is basically how it works. Now we are going to cover two more keywords, the break keyword and the continue keyword. The break keyword is used to exit the loop, for loop or while loop. So let's take this example. For I assigned 1 to 10, we increase by 1 here, so we can omit it. We're going to display this text, hello, this is a loop number. And then in this line, we have the if statement. And just to let you know, the for loop body consists of statements, like here. Okay, so we have we have statements. And each of these statements could be any kind of statement. So it could be if statement, could be another for loop, could be another while loop, and so on. So it's valid to have a statement 1 as if statement, or another for loop. So we have I changing from 1 to 10, and we are writing this message to the screen. We check if I square equals to 64, then we are going to break. If we break, it means we are going to exit the for loop without proceeding with any other statements or any iterations. So this text is going to be written to the screen or the command window. So hello, this is a loop number. And then this code is going to check if I square equals to 64. So 1 square is 1, so it does not equal to 64. So this code is not going to run. This break here is not running when I equals to 1. MATLAB is going to skip this code and move to display I. I will be displayed and I has a value 1. And then we display this message, check this condition again, 2 to the power 2 is 4, it's not equal to 64. So we skip this code and so on until I becomes 8. And we check I to the power 2 equals to 64. So this is true, this condition is true, and then we break. When we break, we go out of this loop without doing anything. So this function that takes I is not going to work when we call break. We are going to run this in MATLAB in detail to show you how it works. But for now, you need to know that break exits the loop without running any further statements. And the continue keyword works in a similar way, but instead of breaking the code, it just skips the current iteration. So what happens here, when this condition is true, when y equals to 3, we're going to continue. Continue here means we're not going to run this code. We're not displaying the value of y when y equals to 3, but then we're going to get back to while. And the value of y now is 3. So we run this statement, and this statement is decreasing y by 1. So y now becomes 2, and then we check y, is it equal to 3? No, so we're not going to continue and so on. So this code is checking if y is 3, do not display y. So basically this code displays 4, 2, 1, okay? Why not 5? Because in this line of code we are decreasing the value of y by 1. So when y is 5 at the very beginning, in this line we decrease it by 1, so it starts with 4. This is the end of this theoretical part, and let's open MATLAB and start having some practical examples. Okay, so now we have MATLAB and let's run some examples. I'm going to store or to write my examples in a script file. I'm going to call it examples. Okay, so let's open this file. The first example that we're going to have, example 1, is a for loop example. In this for loop example, I'm going to show you some statements that are going to be repeated, and those statements are not dependent on the counter or the index, right? So let's, for example, have for I assigned 1 to 10, right? And then we're going to end it, and here we're going to run our code. So just display hello world. So if we run this, hello world 10 times, okay? And I said in the slides that if the step is 1, it's equivalent to just removing the step, okay? So if we run this, it's going to give us the same code, nothing changes. Okay, so this is the first example, very, very basic and easy example. Let's get to the second example, or example 2. I equals 1 to 5, for example. I'm going to end this, okay? And here I'm going to run some code. This, then this is, and then in the second line, display I. Okay, so what happens is I is set to 1 and this statement is running. It does not depend on I, so it's going to display the same message, the exact same message. And then after that, this statement is going to run, and this one depends on I, so I now is 1, so it's going to display 1. And then the code starts back from here again, but now I change it to become 2. So now I is 2, this is going to run again, doesn't depend on I, and then this is running again, and it depends on I, so I becomes 2, so 2 is going to be displayed, and so on until 5. So I'm going to run this and see. Okay, there is one thing I want to show you. We can just select this code and run it. We don't have to run everything, so we can just select this code, right click, and evaluate selection. Okay, so we can see here, this is the first statement. Okay, so this is a iteration number, and then 1 second statement, and so on until 5, right? Okay, very straightforward. Now let's have another example. I'm going to add a section, and this is example 3. For I from 1 to 100,000, x of I assigned I, and then end. We are having a vector, we are creating a vector x. The elements of x are taking some values I. The first element is taking the value 1, a second element is assigned the value 2, third element in x is assigned the value 3, and so on until we reach the element 100,000. So let's run this and see how it works. We can just run section. So we ran this section only because we are on this section. So when we run section here, the code is going to run for this section only. Okay, and now we have x. X is a vector of 100,000 elements, and if we open it, we can just double click on it and we see the elements. So the element number 1 has 1, the element number 2 has a value 2, and 3 has a value 3, and so on until the last element. Just ignore those ones. This is the last element. So here you can see x is underlined. Why x is underlined? We have a warning here, and basically this warning is saying that you are changing the size of x. I'm going to explain why, but to fix this, we can just initialize the whole vector first. X assigned zeros of the size 100,000. We are initializing x by a vector of zeros, okay, of this size. Then we do not have any warnings here. In fact, this is one of the very common mistakes that new MATLAB developers are making, is when you do not initialize your vector and you initialize it inside the for loop. This is very heavy to compute, so many programs are very slow because of that. Why is that? Let's clear x first. MATLAB works this way. So when you say x at 1 assigned 1, MATLAB will create a vector of size 1 by 1 and assign it the value 1. And when you say x at 2 assigned 2, now MATLAB is confused. X has only one element or two elements. So when you do this, you are just changing the size of x. And this is expensive in terms of time, because what happens is MATLAB is going to erase this one from memory, this x, and create another one that contains the old one and the new one. So we have now x is of two elements, the first element and the second element. And when you do this again and again and again, that means that each time you want to do that, you're asking MATLAB to erase the old vector and recreate another one that contains all the old elements and so on. Okay, so this is very time consuming. The best way to do that is to create a vector of a fixed size, so MATLAB knows that it's of 100,000 elements, and then those elements are assigned 0. And you want to modify the 0 to be something different from this code. So try not to use a code that is changing the size of a vector or a matrix, because it's heavy on the computer and expensive. So let's clear x and then CLC. Okay, so we can run one section only. So we are on this section, so I'm going to click here. Okay, and we can see here that x has those elements. Now let's run another example. So let's create another section, and for this section I'm going to write example 4, and in this example I'm going to read the values. So in this example here, I was trying to have a vector x and write to this vector some values or assign some values to it. Now I have x already in memory, okay, or in the workspace, and I want to get the values of some of the points. Let's say I want to display the values from the element number 10 to the element number 20. I'm going to say for I from 10 to 20, do what? Disp x at I, and then end. So I starts at 10, and then we run this one, so we display x at element number 10, and then we go back here and I increases by 1, it becomes now 11, and then we run this statement, display x at 11, and so on. Okay, so let's run this section from here, 10, 11, 12, 13 up to 20, right? And we can add the step, so we can step with 3, so that means the first element is going to be 10, the 10th element, so display x at 10. Then in the second run we add 3 to 10, so it's going to be 13, and the third run I is going to be 16, and the fourth run I is going to be 19, and in the fifth run I becomes 22, so it's not going to run because our range ends at 20. So I'm assuming that the display will be for 10, 13, 16, and 19 only. Okay, so let's run this section. Yeah, so 10, 13, 16, 19. Now I'm going to use a nested for loop. Nested here means I'm going to have one for loop inside another. Add a section, example 5. And let's create a matrix, okay, of 2 dimensions. That means it has a length and width. And this matrix might be 5 by 5. We can initialize it. So we can say zeros. And then I can now say for I from 1 to 5. And this must be the number of rows in A, because in MATLAB we are moving from the first row to the last row. And for each row we move element by element in this row, which is the column. And then we are going to say here end, and we can say A at I, this is the row number and everything. Okay, that means we're going to take the whole row, and we know that each row in A has 5 elements because A is 5 by 5. Then we could say 1, 2, 3, 4, 5. When we do that, A becomes a matrix. Each row of this matrix is just like that. Run section. So A. But what if we want to change this line and this line and this line and this line dynamically? And instead of having this, we can just add an index j. And we want j to move also from 1 to 5. Okay, so we can say for j from 1 to 5, and then move this and this is going to be only one element, and this element is going to be maybe I plus j. So it depends on I and depends on j. So when I is 1 and j is 1, this is going to be 2. Okay, so A at 1 and 1 here is going to be 2, but we want this to be 1, so we can just say minus 1. Okay, so when I is 1, j is 1, this is going to be 1 here. When I is 1, first row, and j is 2, this is going to be 2 because 1 plus 2 minus 1. Okay, so let's see how it runs this section. So run this section and check A. So A becomes 1, 2, 3, 4, 5. Okay, and we want here 6, 7, 8, 9, 10, and so on. So we can say we want this element to be 6. So this could change to I times 5. If we are in the row number 1, I times 5 is going to give us 5. Okay, and then we add the j element, right? But I times 5 here, if we are in the first row, that means we start at 5. We do not want to start at 5, we want to start at 0. Okay, so we should say I minus 1 times 5. That means if we are at the first row, I is 1 minus 1, so this is 0, times 5, it's 0, and then plus j. So when j is 1, we are here. When j is 2, we are here, and so on. If we are in the second row, I is here. 2 minus 1 is 1, times 5, it's 5, plus j, and j in this location is 1, so this is 6. Okay, I'm going to remove the semicolon to show you the result. directly. Okay, so run. Okay, 1 2 3 4 5 6 7 8 9 10 and so on up to 25. I know this is tricky, but you have to work on it. It depends on your application. How to fill a matrix, how to come up with this formula is based on your software or your program. But what I wanted to show you here is that we have some loops that could be nested and could depend on the I and j. So this is one statement that is running several times, like 25 times. Okay, each time it runs, the output or the result is different. So when it runs here, it's 1 and 2 and so on, because it depends on I and j. Okay, so this is basically what I wanted you to know from this example. I'll stop here at this point, and I'm going to continue the second part of this lecture in the next video. I hope you enjoyed this video, and I hope you gained some knowledge from it. If you like the content of this video, please subscribe if you're not subscribed yet, and share it so that it can reach other people. Thank you, and see you next time.